Hello math students. Today's video is lesson 3.2, which is greater. In today's lesson, we are going to be comparing various functions and we are going to put them in order from least to greatest under three different scenarios. Number one, it says we want to put the expressions that I give you in order from least to greatest when the value of x is 0. So what I'm going to do is I am going to plug x equals 0 in to each of the expressions that I give you. I'm going to plug in x equals 0. And then I'm going to compare what I get for my answers. So for the first one, I have 2 to the x. So I'm looking to see if I go 2 to the 0, my answer is just a 1. Because any number with an exponent of 0 is just equal to 1. On the second one, x squared minus 20, if I go 0 squared minus 20, my answer is a negative 20. The next one, same kind of thing. I'm going to replace all of the x's with 0. My answer that I get on this one is a 1. X plus 30, when I plug in a 0, I get a 30. X to the 4 minus 1 gives me a negative 1. The next one gives me a negative 4. And then the last one gives me a 0. So all I need to do now is put these in order from smallest to biggest. You will notice that 2 to the x and x to the, x to the 5th minus 4x squared plus 1 do give me the same answer. So it doesn't matter what order I put them in. So I could have also switched those and would have been just fine. Number 2 asks me to put the expressions in order from least to greatest when x represents a very large number. So we're saying this number is so large that it is close to or approaching positive infinity. I can't plug numbers that big into my calculator. So what I'm going to do is I'm still going to choose a big number, but I'm going to maybe choose x equals 100. So I'm going to plug 100 in for x on each of these. With 2 to the x, if I look to do 2 to the 100, I plug it into my calculator, it looks kind of funny. So it looks like, if I just look at it without looking very closely, that it's just 1.26. However, if I look at the very end, there's this E30. This means move the decimal point 30 places to the right. So 2 to the 100 is really more like 1, 2, 6, 7, 6. And then from here all the way to the end of the number, there should be 30 digits. Another way that I could write this is I could say that this is approximately 1.27 times 10 to the 30. So 2 to the 100 is approximately 1.27 times 10 to the 30. That's a really big number. When I plug 100 in for x squared minus 20, that gives me 9,980. When I plug in for the next one, that gives me 960,001. X plus 30 gives me 130. X to the 4 minus 1 is 99,000,000. 999,999. X to the 3 plus x squared minus 4. When I plug in 100, gives me 1,009,996. And finally, negative x squared plus 3x gives me negative 9,700. So when I go and put them in order from smallest to biggest, this is what I get. Number 3 is once again a similar kind of thing, except for it's asking me to put them in order from least to greatest. When x represents a number that is approaching negative infinity. Once again, plugging in a number that's getting really close to negative infinity is going to cause issues with the calculator. So I am going to plug in x equals negative 100 instead. When I plug negative 100 in for 2 to the x into my calculator, it looks something like this. Once again, if I don't look super closely, it looks like it's just 7.89 approximately. But I still have this e to the negative 31. Because it's a negative, that means move the decimal point 31 spots to the left. So my number here is really 0.000, a bunch of zeros, and then a 7. This is 31 digits. And then we've got the 888, etc. So this number is pretty darn close to 0. X squared minus 20. When I plug it into the calculator, I have to be really careful. I need to make sure that I put parentheses around the negative 100. If you notice what happens if I put negative 100 squared with the parentheses, it gives me 9,980. However, if I don't put the parentheses, it gives me negative 10,020, which is a lot different. What it's doing on the second one is it's squaring 100. After it squares the 100, it makes your answer a negative. What we really want to do is we want to do negative 100 times negative 100, which is a positive number. So x squared minus 20, if I plug negative 100 in, is equal to 9,980. When I plug x to the 5 minus 4x squared plus 1 in, once again, it gives me kind of that weird looking answer. This looks like it's approximately negative 1, but I still have this e to the 10. So I'm really moving the decimal 10 places to the right. When I went and plugged this into a better calculator than the calculators we have, I got that this is my answer. Negative 10 billion 39,999. So that's a pretty negative number. When I plug negative 100 in x plus 30, it gives me a negative 70. For x to the 4 minus 1, it gives me 99,999,999. For x cubed plus x squared minus 4, it gives me 990,004. And that's a negative. And then on negative x squared plus 3x, it gives me negative 10,300. When I go put them in order from smallest to biggest, this is what I get. So we're going to look at each of these three, and we're going to make some observations about maybe why things are the way they are. Before we do that, I need to go over some vocabulary that we are going to need in order to understand how to describe the patterns. The first word is the degree. The degree is simply the biggest exponent. So on this example I have down here, this is one of the ones that we were putting in order. The biggest exponent is a 5. So I would say this is degree 5. The next thing we have is the coefficients. A coefficient is just the number that's being multiplied by the variable, or simply the number in front of a variable. There's a specific type of coefficient that we're going to be talking about today. It's called the leading coefficient. The leading coefficient is the coefficient of the term that has the biggest exponent. Or in other words, it's the term or piece of the polynomial that we get our degree from. So on this example, I get my degree from this x to the 5. I don't see a number written in front of x to the 5, but there's really a 1 there. So I would say here my leading coefficient is a 1. So let's go ahead and look at 1, 2, and 3 individually. I'm actually going to start on number 2. So we're going to look at the behavior of functions as x gets close to positive infinity, as x gets close to 0, and as x gets close to negative infinity. One thing that we hopefully noticed as we were putting these in order, on number 2, at this line right here, everything above it, we got my answer when I plugged x equals 100 in as negative. Everything below this line gave me a positive answer. One thing that we should notice is that this leading coefficient on the first one is a negative number, but for all the other ones, my leading coefficient, there's a positive number, which is just 1, that's in front of each of these polynomials. So if I have a polynomial, so if I have x's with whole number exponents that are added together, so really I don't have any decimal exponents and the x isn't in the exponent. If my leading coefficient is positive, my y values are positive. So my y values are going to be positive if the leading coefficient is also positive. We also can say that my y is going to be negative if the leading coefficient is negative. And then another thing that we should notice, as I went from x plus 30 up to x to the 5 minus 4x squared plus 1, my exponents increased. So I'm going to say the bigger the exponents you have, that means that we're going to have bigger outputs. Or if my leading coefficient was a negative, I would say more negative. And outputs I can also say is y values. And then exponential functions are always going to be the most positive, or I'm going to say the biggest, just because they are the fastest growing. Another thing that I want to notice or point out with these, when I'm saying that we're close to positive infinity, a shorthand way of writing this is x arrow infinity. This just means x approaches positive infinity. I'm now going to go back to number 1. So I want to just kind of look and see what happens at 0. So with this one, I'm plugging in 0 for x. One thing that we hopefully noticed, for all of the polynomials, so the negative 20, so for the first 5 and the last one, my answer was this number that didn't have the x. So for polynomials, you're just going to look at the constant term, which is the one without an x. When we're looking at 0, this is really the y-intercept. So we are looking to see what is the y-intercept. We are going to end by looking at number 3. So we're seeing what happens as I get close to negative infinity. Another way that I could write that is say x arrow negative infinity. This means x approaches negative infinity. Let's look at what we got for our answers on number 3. So the point where we changed from positive to negative was right here. Everything above this line was negative. Everything below this line was positive. And then in between them was just 0. So the x to the 5 minus 4x squared plus 1, x to the 3 plus x squared minus 4, and x plus 30. When we did number 2, these 3 all gave me positive. We had them, they were positive. But now they are negative. If I look at the exponents, all 3 of these numbers are odd numbers. For the other 3, x squared, negative x squared plus 3x was negative when we did number 3. X squared minus 20 was positive, and x to the 4 minus 1 was positive. So if I have an even power, it's going to stay the same as it was when x went to positive infinity. If it was positive before, it's going to stay positive. If it was negative before, it's going to stay negative. So I'm going to say if the biggest exponent or degree is an even number, then the left and right sides of the graph are going to be either both positive or they're both going to be negative. However, if the biggest exponent is an odd number, then the left and the right sides are going to go in opposite directions. And then exponential functions always are going to approach 0. If I was to look at the graph of an exponential function, it looks something like this. So as I go to the right, it's growing really fast. As I go to the left, it goes to 0. An odd degree function is going to look something maybe like this. As I'm going to the right, it's going up. As I go to the left, it's going down. Or I could even have something maybe like this right here would also be an odd degree function. As I go to the left, it's going up. As I go to the right, it's going down. An even degree function would maybe be something like this, like a parabola. Both sides are going up, or both sides go down.